Welcome to 59th lecture in the course of Industrial Engineering and Operations Research. We are discussing probabilistic inventory models, and in that connection we discussed some problem of a single period model. It was based on the book Design and Analysis of Lean Production Systems, authored by Ronald G. Askin and Jeffrey B. Goldberg. It was published by John Wiley and Sons in 2002. So, we are going to tell about single period model. Example is like that a newspaper person purchases newspaper in the morning just for a day and then sells whatever newspaper is not sold, that is somewhat get wasted or disposed of at some price. Similarly, suppose a vegetable seller is there, he also purchases the vegetable in the morning and maybe consumes it in one day or maybe at most 2 days, like that. So, we are following some notations. C is equal to purchase cost of each item. Purchase cost of, it may be production cost if there is a factory, otherwise it can be purchase cost. P is equal to price per item sold, it will generate revenue. S is equal to salvage value of each unsold item. It may be 0 some cases you may get some amount, that type of thing can be there. D is the demand. Demand is considered as a random variable with probability density function Fx. So, there is a probability of demand. Okay, demand can be 10 unit also, it can be 15 unit also, but for that there are different probabilities associated. So, we use considering that demand is continuous, we use probability density function Fx. Okay, that means if in certain range, suppose how much is the demand between x and x plus delta, that means demand value is either x unit or x plus delta unit, that probability will be Fx multiplied by delta, that will be the probability. L is equal to shortage cost for each unmet item demand. Suppose you could not supply to the person, customer, then he may get dissatisfied, and in a way you can, his dissatisfaction can be converted in terms of the money, and that can be considered as a shortage cost. Or there are other ways also, you can also consider that how much profit you are losing. And Q is equal to number of units ordered, which is a decision variable, that how many units I should order considering this probabilistic situation. So, this is that can be considered decision variable. In this book L has been written as pi, but I have used the symbol L because generally in engineering we know that pi is the ratio of circumference to diameter of a circle. So, therefore, we have not used pi term here. Now, expected profit is how much profit is expected in two situations. Suppose by the way your demand is more, but you ordered less quantity. So, Q is smaller or equal to D. In that case, profit will be P minus C into Q, because obviously per unit price is P and cost is C. So, P minus C gives profit, profit multiplied by Q, number of unit, that is you did that, but you will also, because demand was more, so you will put some loss or something due to not this one shortage cost. So, therefore, minus L D minus Q has been added, that means it is a type of penalty you faced. And suppose the quantity Q is more than D, in that case the profit will be P into D, because I sold suppose D quantity, okay, so P into D minus C into Q, okay. Because demand was D, so you cannot sell more than the demand. So therefore, revenue generated will be P into D only, because price is P. But minus CQ has been subtracted here. That means because you purchased Q quantity only, so that means Q is more than D, but you have to pay that. So PD minus CQ will be there. It will not be simply P minus C into D, because you have spent this one, and plus S into Q minus D. So Q is, so this is the excess. So S means, because we use the system salvage value, so we had excess Q minus D units will be remaining, because demand is only D only. So those remaining things can be sold at a price of S rupees. So therefore S into Q minus D. So that is the thing. So how can we combine that, and what is Q? In fact, Q can take on any value with different probabilities. Okay, so that's why we are putting like this. Okay, rather not Q can take. Q is the decision variable which we have to find. D can take on any value. D is not a fixed quantity, it has some probability type of thing. So we have to say that, let us say that what is the expected profit. Okay, expected profit is P x fx into dx. So fx dx is the probability that there will be x units will be sold. So that means 0 to Q. Okay, we go from 0 to Q. Okay, so that means this is the profit multiplied by this one x fx into dx. So we are taking weightage about that type of thing. That means between 0 to Q, this is the type of thing. You can say that this is the expected value, and plus S 0 to Q, Q minus x into fx dx. So that means Q quantity was ordered, but suppose you sold only the x quantity have been sold. So exchange is Q minus x. Okay, and this can be 0 to Q only, because shortage will occur provided x is smaller than Q. So therefore 0 to Q fx, and this is small s only, this is small s. Okay, and this is Q to infinity. Suppose demand was between some value between you ordered quantity Q, but demand was say something more than that, to Q to infinity, but this will be Q times fx only. Okay, that type, and dx to Q times fx dx into P minus L Q to infinity. L is that cost of we have said that lost cost, because you could not give the full quantity. So therefore Q by infinity x minus Q. Okay, fx, because suppose you have only purchased Q unit, but demand might have been more. So therefore suppose demand is x, so x minus Q is the thing units you are not able to supply, and for that probability is this much fx dx. So fx dx into x minus Q, this will be type of loss to you. Okay, and minus CQ, because anyway you have purchased Q quantities, so minus CQ you paid. So therefore this is the thing. So plus quantities are what we gained, and minus quantities to minus quantity what we are going to lose, and this overall it gives the profit. So you can see the first term is basically revenue when demand is less than the supply. Okay, and second term is the salvage value. This is the salvage value, and third term is that revenue when demand exceeds supply, and fourth term is shortage cost, fifth term is cost of goods. Okay, so we have done that type of thing. Now in order to maximize the profit with respect to Q, because Q is the decision variable which we can change, so we have to make dE by dQ is equal to 0. That is the necessary condition for maxima or minima. So we have to do that. But here if I do dE by dQ, you see there are some Q's in the integrand here, but there are in the limits also Q is there. So this derivative also many people may not be knowing or may forget. So, therefore, let us revisit something from the calculus, okay, and we will find. First, you have to see dE by dq, d by dq is equal to 0, we have to do that. So, we use the Leibniz integral rule. Leibniz was born in 1646 and died in 1716. He was a German polymath, active as a mathematician, philosopher, scientist and diplomat. Even it is said that he developed the calculus, but some people say no, Newton developed the calculus, like that there is a something controversy about that. And but he developed many other things also. He means worked on those areas, binary arithmetic, statistics. So, Leibniz has been called the last universal genius due to his vast experience across fields. That means he worked in many fields. So, by Leibniz rule, suppose I have to do this derivative, that means f(x, t dt, and this is ax and bx, limits are, that means a is a function of x and b is a function of x, and here this function also contains x, but there is a definite integration is done with respect to t, some other variable, and then you have to do that. So, if it is like that, so what you have to do that? It is simply f(x) calculated at bx, okay, function instead of t you put bx and then say dbx by dx minus f(x) ax dax by dx, and plus you keep the limits ax bx. Now, you take d by dx inside. So, these things you have to do that. Suppose a and b would have been constant, not a function of x, then I would have considered that derivative can be taken inside. Otherwise, you have to take care about this boundary thing. I am not giving the derivation of this. If anybody is interested, he or she can refer any calculus book of the graduation level. Now, so I am just giving example. Let us say you need not remember the formula, it will get internalized with you soon. Suppose you say, suppose f(a) is equal to 0 to a sin x square dx, if f(a) is equal to like that. So, naturally f is a function of a, because x is just a dummy type of variable. If you do definite integration, then this will actually vanish. So, now we have to do df by dA. So, what should I do that? Function sin x square. So, I put sin a square and then dA by dA, because this limit. So, this becomes sin a square. So, it simply became sin a square. Otherwise, it is very difficult to make the derivative without Leibniz rule, because you cannot integrate properly that sin x square dx. Okay. Then suppose another example, suppose f(x) is equal to x 2x ln 1 plus t square dt. Here also f is a function of this. Then df by dx is ln 1 plus t square, same function, but they put the value instead of t, put the 2x. That means upper limit. Okay. So, 4x square, and then d2x by dx, because upper limit is 2x. Then minus lower limit minus ln 1 plus x square. In place of t, I put x, and then dx by dx. So, this becomes ln 1 plus x square d2x by dx minus ln 1 plus x square, and this becomes 2 ln 1 plus 4x square minus ln 1 plus x square. So, this is. Now, suppose I give another example. Suppose f theta is equal to 0 to pi cos theta sin theta t dt. In these limits are constant. So, df by d theta will be simply d by d theta. That means you take the derivative of the integrand inside the integral sign, and it will be d by d theta cos theta sin t dt, and this if you differentiate, this is becomes minus sin t sin theta sin t dt. Okay. Now, suppose f(x) is equal to x square t sin tx dt, then df by dx is equal to x square sin x cube dx square by dx. Why x cube? Because instead of t, I put x square in the function upper limit. Then minus x sin x square, because I instead of in the function I put t is equal to x. So, x is sin x square and dx by dx plus limit x to x square t square cos tx, okay, because now I am differentiating inside the integral with respect to x, and if I differentiate with respect to x, I will get t outside and t square cos tx dx. Simplify this, this becomes 2x cube because dx square by dx is 2x. So, 2x cube sin x cube minus x sin x square plus x to x square t square cos dx dx dt. So, you have if you integrate this whatever way, numerically or whatever way, you can get the answer in the whatever form you need. So, using these Leibniz rules, if I differentiate dE by dQ, so this will be like this, and which will become, suppose you differentiate this with respect to q, so this becomes PQFQ, because simply you have to differentiate, you have to put the value of q in the integrand and you differentiate dq with respect to dq, it gives dq, other things not needed here, this is not a function of q. Similarly, the second term gives 0 to q s fx dx and minus, but one differentiation, if you see that first term will be q minus x, but if you put x is equal to q, then q minus q is 0. So, ultimately it will come this only, and then it is minus PQFQ plus q to infinity pfx dx, you can see by applying that same rule. And similarly, here if I differentiate, then it will become L fx dx and minus cq is differentiated by c. So, you can actually see that okay, infinity will also be considered as a fixed limit, okay, it is not a function of q. So, therefore, that thing it is a function of q. So, that term will come, but you know x minus q is 0. So, if you simplify and suppose I put say 0 fx, okay, 0 to q and this fx dx, okay, q quantity, and this I put it as a fx, okay. This is cumulative probability distribution up to that point, okay, 0 to q, you have ordered q quantity. So, this is fx. So, therefore, if I put like that, and this will become basically fx, okay, and you can see that here this gets cancelled also and these remains. So, 0 to q fx, but you know that it is a probability distribution. So, 0 to infinity fx dx is equal to basically 1, but 0 to q fx dx is fx. So, therefore, q to infinity fx dx is equal to 1 minus fx, is it not, 1 minus fx. So, therefore, what we can do, that we can write that this is q to infinity. So, this is p plus L 1 minus fx and this is s fx minus c, and this has to be set equal to 0 because we are finding d by dq equal to 0. So, then we will get the optimum quantity q star. So, therefore, optimum quantity becomes f q star is equal to L plus p minus c divided by L plus p minus s. So, we can, from this it is obvious, p plus L plus p minus c. So, numerator is basically lost net revenue, okay, that is plus shortage penalty L, that is this one. So, this is something like p minus this one c, okay. So, therefore, we have p minus c per unit, we have price and this much. So, we have lost net revenue. So, this much revenue is lost because suppose my price was 10 rupee and I had purchased in 5 rupee. So, 5 rupee difference, this profit I would have made, but that profit is gone. So, therefore, this is p minus c and plus this is penalty due to shortage, we have put L plus p minus c, and denominator is basically the same thing. That means, whatever this upper term is there, but in that we have added C minus S. You can see that if you add L plus P minus C plus C minus S, then you get this thing. Okay, because so this is C minus S is basically same plus loss from each unsold unit. That means C minus S. C is the cost in which you have purchased and S is the salvage cost, that is salvage value. So, therefore, C minus S is the loss. That means, if I purchased one newspaper in 10 rupees and in the evening I had to discard it in 2 rupees. So, therefore, naturally 8 rupee will be my loss. So, now we can write a simpler expression. We can in fact say salvage cost per unit CS can be said as L plus P minus C, because it is the salvage cost, because it is due to penalty. That means, you get the penalty of not giving L, and also P minus C, because P minus C profit you would have got. So, this is a total thing together gives the salvage cost per unit. Okay. This L data will also be available to you. Say, for example, if you purchase something in 10 rupees, sold in 15 rupee, so P becomes 15, C becomes 10, so 5 rupee profit you are losing, plus L penalty because you have annoyed the customer. So, 3 rupee per unit you keep for that also. So, this will be total salvage cost, and this is C0 will be C minus S, that is over stock cost. We say that whatever loss we made in purchasing something, okay, that is over stocking. So, this is this one. So, FQ star will be CS divided by CS plus C0. This much we had already said that, and it is a type of, some people call it a service level also. Now, we can also see we have not done the double derivative test, because whether it is really maxima or minima, that also have to be done. So, dE by dQ is already we have written like this. Now, you differentiate with respect to, again with respect to Q one more, d square E by dx dQ square, Q is equal to Q star, and this becomes S F Q star minus P plus L FQ star, and this is basically, obviously it is a negative quantity, because S P plus L will be more than the S. Okay. So, that means, because salvage value cannot be very high, salvage value has to be less only. So, it cannot be more than the price of the product. Okay. So, in fact, S minus P itself is negative, okay, because price you are this one. Okay. Now, let us do that one problem. A newspaper operator needs to decide how many papers to stock each morning. Each newspaper is purchased at a cost of rupees 12 and sold for rupees 20. Maximum sales takes place between 6 AM and 7 AM, making the demand effectively immediate. Okay. So, he does not have to hold anything. Any unsold newspaper at the end of the day are recycled, earning rupees 2 per copy. Given that the daily demand follows a certain distribution, how many copies should be ordered each day? In two scenarios, one is there is a normal distribution with mean 300 copies and standard deviation 20 copies. Other is, suppose there is a discrete PDF has been given to you, that probability that 200 copy will be sold each 0.1, 250 will be sold each 0.4, like that. If that type of scenario is there, then also that is also there. So, solution: each unsold copy will cost the owner rupees 12 minus 2 is equal to rupees 10. The penalty for running out of stock is rupees 20, because he would have earned rupees 20, and 12 was the cost. Therefore, rupees 8 per copy was his profit, and holding cost per unit H is equal to rupees 10 per copy per day. So, holding means basically each unsold copy costs rupees 10, so that much, and penalty cost P is equal to rupees 8 per copy. So, the critical ratio we call, some books will say CS by CS plus CO, others will say P by P plus H, but basically both are same thing. So, 8 divided by 8 plus 10 is equal to 0.44. So, we got that this one. Now, consider different cases. The demand D is normally distributed and 300 to 20. So, using the standard normal table, you find Z is equal to D minus 300 by 20. From the normal table, P Z is is smaller than this one is equal to, and D is demand. Okay. So, it is equal to pi is equal to 0.44. That means, this is you have to find out which z value will give the probability equal to 0.44. So, therefore, in the table you can see that this area will be 0.1. Okay. So, that means, when z is equal to less than 0.114, that means, in this side of this one it is in this side of this one z is equal to, this is minus 0.1, let us say you total area is 0.44. So, this will come from the table. Then y star minus 300 by 20 is equal to minus 0.1. Okay, because you have to denormalize now. So, instead of this you put that y star, or y star is equal to 298. So, solving y is obtained as 298. Okay, that is the answer. In the second case, if the demand D follows a discrete PDF, first the cumulative density function is determined. You keep determining, this is 0.1, then this will be up to 0.5, then this is 0.7, this is 0.8, and this is 1. Okay, up to 200 you have to keep adding that 0.5. This probability was 0.2, so it becomes 0.7. Now, critical ratio is 0.44. So, naturally that it is below 250 and after 200. So, therefore, you order 250 copies, because you can order only discrete quantity. So, setup model, sometimes what happens that in this we have not considered any setup cost, but you can consider the setup cost also, in which this is setup cost is there. So, that means, this I will be just telling that setup model. I will be moving little fast. It is nothing that you have to say that same type of curve comes, but you know it becomes a k plus ECY expected cost. Present model differs from no setup model, that setup cost is incurred. So, therefore, expressions will be almost same, but plus k will be added. But plus k is not a function of q, that means, it is not a function of y. So, therefore, optimum value of y, here instead of q I have written y, because now again I am following Taha notation. This is from Taha, that one was from different books. So, I use q, but here if I differentiate with respect to y, then k does not contain that. So, therefore, formula comes same. So, because k is constant, the minimum value of ECY must also occur at y, even with the setup cost also it will be like that. So, situation may be like this, that as such without setup, if this is the graph, with setup you will get another graph, but the minimum is basically same. Okay. Now, how much should be ordered? This is taken different type of cases, that you know that you can make the expression, but here that if we say that suppose we draw a line from here to here and it cuts this point here, that point is called S and this is S1. So, we say that suppose x is smaller than S, that means inventory in hand is smaller than S. What happens? Then inventory is between S and S, and inventory is more than x. These three things are there. Okay. So, in that you can I will not go in much detail about that thing. That means, you can argue that if it is suppose you are here that x is your quantity in hand is less than this one, then naturally that this point is much below that. So, therefore, if you order it, you will get some minimum cost, but in the other cases if your quantity is here, then if you order more, then you will not get the loss. So, while skipping those details, I am just giving the summary, and it says that if x is smaller than S, then order S minus x quantity, and if x is greater than S, do not order. So, I will make it clear with that an example. An item experiences a one time demand that occurs instantaneously at the beginning of a period. The demand follows a uniform probability distribution ranging from 0 to 10 units. The holding cost is rupees 5 per unit for the duration of the period, and there is a penalty of rupees 40 per unit for any unmet demand. Additionally, every order placed incurred a fixed cost of rupees 100, determine the optimal inventory policy for managing this item. So, simply P is equal to 40, that means we get for the, and there is penalty of rupees for any unmet demand. So, penalty is 40 and H is equal to holding cost is 5. So, critical ratio is obtained P divided by P plus H, that means 40 divided by 40 plus 5 is equal to 0.89, and then we say that P D is smaller than Y is 1 by 10, because the uniform distribution, this becomes like this. So, thus S is equal to Y star is equal to 0.89 by 10, and this is 8.9, because this probability is 8.89. So, we put this one, and expected cost function EECY is equal to 0 to Y 110 Y minus D D D 45 1 by 10 D minus D. So, this expression provides you this, and if we add the setup cost ECS is equal to K plus ECS. So, if I put those, if I equate these two expressions, this is 2.5 S square, this one. So, we get S is equal to, and we put S is equal to 8.9, because S has come 8.9. So, solving this, we get small s is equal to 15.32, and this becomes 2.62. So, therefore, however, S is greater than S, so that is discarded. S is equal to 2.28 or 3 units is taken. Hence, if unit in hand is less than 3 units, then order the quantities to make 9 units in inventory, okay, because 9 means 8.9 is the this one, otherwise do not order. Okay. So, that type of thing you can do that setup model with setup, okay, and that is all I want to say in this lecture. Then I will tell the last lecture on this topic. Okay. Yeah. Thank you.